Hi, welcome back. This is building an iOS app with C#, Module 4, Video 4. In this video we're going to design and build out our state service. Alright, so let's start with the contract as per usual. State folder, and we will just call this state service. Alright, so the interface we want, basically the idea of this service is to allow us to store and retrieve little bits of state, and we'll be using this, for example, when we tombstone the application, we want to remember where the user was in their exercise program so that if needs be we can resume from that point later on. It's going to be a generic service, so it's not going to have specific methods. It's just going to be, get me this piece of state for this key, save a piece of state against this key, etc. It's going to be asynchronous as well. For example, our method to get some state can look like this. So you give it the key and it gives you back the state of type T asynchronously, because we don't know, how that state's going to be stored. Presumably, you'll see when we get to the implementation that we're going to use a third-party library called Akavash, if I'm pronouncing that correctly. But essentially we need to make sure that retrieval and saving of state, working with state in general, is asynchronous. So similarly, our set method will take the key, and of course it will take the actual value you want to set. Let's have a remove as well. Let's have the ability to force a save. And just thinking ahead a bit, I think we're going to need some kind of way of registering a callback so that when a save occurs, we can provide some functionality to execute. So what we're saying here is, when a save occurs, I want you to invoke this func. It will be passed an instance of the state service, and it will give it back it will return a task to execute while saving. And what this means is, for example, our view models don't need to care about hooking into some kind of event or whatever for saving their state. All they need to do is register their callback with this method, and it will be called automatically when state needs to be saved. So I think that will simplify view model implementations a bit. Okay, let's just create a stub implementation here. Okay, and let's start writing some tests for this. So first of all, when we call save async, we need it to execute all the tasks that we've registered. course this needs to be asynchronous so that we can do an await here. And of course once we've saved here, we expect both of these Boolean values here to be true, because we have registered these two tasks to run when we save, and the tasks simply set those values to true. Okay. Next up, let's make sure that save async does not fail if one of our callbacks does something wrong. So if the save callback fails, so we'll register a callback that does something dodgy. Let's just throw something. Oh, Xamarin, please don't do that. Right, so if we await that, we expect no problems. We just want our state service to kind of deal with that. Probably just by logging it. Next up, let's make sure when we do call this register save callback method, it will throw if the func that we pass into it is null. So register save callback throws if, what do we call that? If save task factory is null. Okay, and this register method is giving us a disposable. The idea being that you can unregister just by disposing of that disposable. So let's make sure that holds true. Okay, so in this case we're storing the handle that we get back from this first registration and then disposing that handle before we call save async. And then of course we expect that the first one did not get called and the second one did. I think that's probably okay, an okay starting point. We can maybe check some simple things as well here, like this key is not null, this key is not null. If you're not familiar with Akavash, it's one of Paul Betz's many projects. The guy's prolific. I'd suggest you check out his stuff if you can. We're also going to be using Reactive UI, which it was his baby. There's more people working on it now, but certainly it was his brainchild. But Akavash is basically an asynchronous caching service or component that we can use, and behind the scenes it will use SQLite, at least on iOS and Android, to store the data that we give it. So let's get started with the implementation. Let's first add Akavash. It's always a bit of a struggle figuring out which one to add. So this depends on SQLite 3. I don't think we want to add SQLite 3. think we just want this portable, which would make sense given they're in a portable class library. Okay, that's been added. Akavash defines an interface called iBlobCache. So that's going to be our means of interacting with Akavash. So we're going to need to take in a blob cache in our constructor, which means we've just broken our tests. That's fine. We'll go back and fix them momentarily. I think we also need a logger service so that we can log errors and what have you. Let's just make sure they're not null. And we'll just store them as locals. As members, rather. Okay, so to get a value, first let's make sure the key is not null. And all we need to do is pass forward the call onto the blob cache. I keep writing blog. Funny about that. Looks like he's updated the API. I remember that being just get object. Cool. What does that return me? Still an observable though. There's one thing I don't really like about these APIs is any asynchronous call that's returning a single item is still manifested in the interface and in the API as an iObservable, which I kind of don't like because iObservable suggests that you could get 0 items, you could get many items. To me, the task type is much more expressive of what we actually want here. So I'm going to convert this iObservable into a task because that makes more sense to me. Thankfully that's really easy because there's an extension method for that. So that's all we should need to get an object. Setting is almost as simple, or it really is as simple. What's it called in? A little bit inconsistent here as well. We've got insert instead of insert async. Key value pairs or insert objects. Okay, this is what we want, insert object. And this should really be insert object async, but anyway. Now removing is called invalidate object, I guess. Let's have a look. Validate object. Yep. That key, and again to task. It needs to know T. Right, so I mean these three methods are pretty much just barely worth testing because all they're doing is forwarding onto the blob cache. We could create a mock blob cache rather and pass that into here and make sure that it's calling it, etc. We may do that, or I may do that after I've finished recording the video and do that as a separate commit. Where our extra functionality comes into play is this saving and registering a callback. So let's take a look at how that's going to work. So when we save, well, let's start with registration. I think that makes more sense to start there. We know that we don't want this to be null. And we're going to need some kind of place to store that. So let's create just a list of them. We don't need any kind of lookup functionality on that. But we will need to protect it. Multi-threading, need to make it thread safe. So we'll need to synchronize access to that. So we use this sync object. Right, so down here what we want to do is lock on that sync object and just register or add that save callback to our list of callbacks. And we need some kind of registration handle. So let's create a registration handle, and we can inherit from our disposable base class that we discussed in one of the last videos that we did. What's it going to need? It's going to need the owner, and I think what I'm going to do is have a private method here to unregister, just so we've got register and unregister as a pair. And all that needs to do, of course, is just lock and remove that from the callbacks. Let's just do a assertion here to make sure that our save task factory is not null. I mean, we could benefit from having a dictionary and then mapping, an integer to the callback, because then removing it would be much faster, because all we need to do is store the integer in the registration handle and then remove using that integer instead of holding onto this save task factory. Is it worth it? I don't think so. Certainly not for this application. We're only going to have, I don't know, probably 4 or 5 view models in total, and only maybe 2 or 3 of them will actually be registering for callbacks. So I won't bother with that here. So instead we're just going to store the actual callback in our registration handle. And our dispose logic is just going to be simply a call into that unregister method. Alright, so that should cover registration, I do believe. So the save functionality, what we need to do there is essentially loop through our callbacks and get the task that it gives us back, and then just wait for all those tasks to execute. So for each save callback, we invoke the callback, passing in this, which is the state service. That will give us back a task. So we convert that into a list of tasks. So now we have our tasks that we need to wait for. We need to be asynchronous here. We want to await task. The task class has a useful when all method, which will wait for all those tasks to complete asynchronously. This is not blocking. And remember, we need to handle errors as gracefully as we can. So let's just catch exception. So let's just log this log any failure here as an error, fail to save, and we can pass through the exception details as well, of course. Perhaps this could be nicer. Perhaps we could have the failure tied back to the actual task that failed somehow. I think this will suffice. And actually, I think that's it for our state service, more or less. Well, we can't run our tests yet because we need to update them. And actually, I think we need to take a little bit of a tangent here, because we need to pass in an implementation of an interface, and we don't have an implementation. I mean, we need to be able to mock this. So what we're going to do, I mentioned this during the architecture video, we're going to use a library of mine called PickleMock to do this. Okay, and the way PickleMock works is it provides some base functionality for mocking. You need to create your own mocks. Eventually I want to have a T4 template to do this for you, but right now it's only just released and it's kind of bare bones, but it's very simple anyway to create mocks. So I'll show you how that works now. We'll actually mock out our own logger service first. So what I'm going to do is create a mocks folder. And we're going to need to mock both the logger service and the logger itself. So let's start with the logger. And basically the way it works is all you need to do is inherit from mock base, give it the interface that you're mocking, and also implement that interface. I hate regions. And generally speaking, in the constructor, the pattern is to take a mock behavior, default it to something. I mean, I default it to strict. You could default it to loose if you want. And you just pass that through to the base constructor. And if you want, you can have some default behavior if it's loose. I mean, if it's strict, you wouldn't do this because that would defeat the purpose of a strict mock. But if it's loose, you may want to avoid problems such as some test code calling into perf. Perf is supposed to return an object, but if we don't set up some expectations here, it won't. It'll just return null. So what we can do is set up some expectations against this mock. So when something calls perf with any string as the message, then let's just return disposable .empty. And same deal when it returns, when it calls perf with the formatting overload. Now in terms of how we implement this mock, all we need to do is use the functionality provided by the base class. This mock base class has an apply method, which we can call for each of our members. And you just need to tell it what member is being invoked here. And it will do the work of figuring out what expectations are being set up, figuring out if it needs to call any callbacks or whatever, and returning a value if relevant. Methods are very similar, so of course we need to use the arguments that we're given. So in this case we don't need to return a value, so we just call this .apply. And now PickleMock will figure out that we're mocking this debug method, and it will even examine the message that gets passed in. So you can set up an expectation, for example, like this. So when debug is called with the message foo, then do something. You know, throw an exception or do some action, and it will only match when the actual message is foo. So in the it class, there's a whole bunch of different ways of examining or matching against arguments. Anyway, this is not a video about PickleMock. I just wanted to explain the basics of it, and that really is the basics of it. So I'm just going to probably fast forward through the rest of this. Okay, and that's it for our logger mock. As you can see, it's a bit monotonous having to, go through all the members and do this. That's why I want the T4 template eventually. Hopefully, probably in a separate package. But yeah, that would make things much easier. So we're also going to want a mock logger service. I might call this logger mock instead of mock logger. It's a bit backwards. Okay, and same deal here. Very similar. I should have pointed out that property setters do have a slightly different syntax just because there's no way to set a property inside a Lambda expression. So in order to be able to do validation against the arguments passed into the property setter, then we have this separate apply property set overload. And similarly, when you're setting up expectations, you say when property set rather than just when. Okay, and for the mock logger service, we need to set up a few different things when it's a loose mock, just to stop things from falling over. We would want, sorry, I haven't done these get logger methods yet. So we would want any calls against get logger, no matter what the type, to return a logger mock that is also going to be loose, of course, so we'll just pass its behavior through. And any access to the entries can just return a empty observable. There we go, that's it for our logger service mock. The other mock we're going to need here is the blob cache mock. I'm not really sure where to stick this, so I'm just going to create a Akavash. Even though we don't have an Akavash service, let's just create a Akavash and then actually, you know what, let's not do it that way. Let's inside our state service we can have a blob cache mock in here. And of course we need to add Akavash to our unit test project as well. Okay, that's that. I'm not going to bother with some loose setup here unless we need it later on, at which point I'll add it then. So that's our mocks that we need right now. So now what we can do is actually pass some instances of those mocks into our state service. Here we go. Right, let's see if we can build here. Nope. Not all CoPaths return a value. Of course they don't, because we forgot to return our, or I forgot to return our registration handle. You guys probably didn't forget, you're probably screaming at your screens. So pass in this and save task factory. Okay, we can build. Let's see if we can run those tests. Success for 4 tests. Okay, great. Right, so that's it for the state service. Of course, I need to go back and format stuff, and I will also add some more tests, maybe do some other cleanup. I've done this with the logger service, for example. So if you wanted to check out what I've done there, just go and look at my commit history in GitHub. Alright, great. Well, catch you next time. See ya.